Dear students, already we have discussed Newton's forward and backward difference interpolation formula, and in that two formulas already we have discussed two very simple fundamental problems. Today we will discuss some more interesting and advanced problems relating to that. Example 1. See, this is the set of data. This is x and this is y. X is 0, 1, 2, 3, 0, 1, 2, and the corresponding data is 3, 5, 9, 15, and you have to find the value, find y of 1.5. Okay, so this problem is important because when we have worked out the problems in Newton's forward or backward, in that case we have considered if this is x and we are observing whether this x is to the upper part or the lower part, but unfortunately here x is equal to 1.5 is exactly in the middle of the data. Then what to do? So let us construct the forward difference table. This is x, this is y. So 0, 1, 2, 3, 3, 5, 9, 15, and forward difference is 5 minus 3, that is 2, 9 minus 5, that is 4, 15 minus 9, that is 6. Then second order difference delta square is 4 minus 2, that is 2, 6 minus 4, that is 2, and no need to go further because now this is 2, 2. Even if you write delta q, that will be 0, so no need to write. X is 1.5, but we will not, for the time being, we will not consider x as 1.5. We will consider x as the unknown. So we know x is equal to x0 plus px. For the time being, we assume that as if we do not know x. So that implies x is equal to x0. x0 is 0 plus p h. What is h? H is 1. That implies p is equal to x. So now apply Newton's forward interpolation. Okay, so that is y of x is equal to y0 plus p delta y0 plus p into p minus 1 by 2 factorial delta square y0 and so on. But as here the data ends at delta square, so we will not write more. So that equal to, what is y0? y0 is 3 plus what is p? P is x. What is delta y0? Delta y0 is 2 plus what is p? X into x minus 1 by 2 into delta square y0 is 2. If you simplify it, that gives 3 plus 2x plus this 2 cancels, that is x square minus x. That gives x square plus 2x minus x, that gives x plus 3. And this is the polynomial what we have found. And now the question is, you have to find y of 1.5. Then in this polynomial you put 1.5, that is y of 1.5, that is 1.5 square plus 1.5 plus 3. Just you calculate the result what you will get, that will be the value for y of 1.5. Finally the result is 6.75. Now we will discuss another problem, that is, this is the set of data. X is 1, 2, 3, 4 and y the corresponding values are 1, 8, 27 and 64. Okay, and we have to find the value of y at x is equal to 5. You see, x is equal to 5 is not within the data, it is outside the data. So when it is outside the data, you have to observe whether it is to the last or it is to the first. Okay, but as the data is outside, we will call this problem as extrapolation problem, but the technique is same as the interpolation, just name is changed. You see how we are working. So in step 1, you form the table, that is x and this is y. Okay, and we will make the forward difference table. x is 1, 2, 3, 4, y is 1, 8, 27 and 64. What is delta? 8 minus 1, that is 7, 27 minus 1, 27 minus 8, that is 19, and this one is 64 minus 27, that is 37. Then delta square is, this is 12 and this is 18, and delta q is the third order, that is 6. Okay, so this is our forward difference table. Right, now we have to apply the back extrapolation, but for backward interpolation, because the x is 5. So here x is equal to 5. As we are applying the backward interpolation, so you consider xn. What is xn? xn is 64. Sorry, xn is 4. So x is equal to xn plus ph. That implies 5 is equal to 4 plus p. What is h? 1, 2, 3, 4, h is 1. So h is 1. So that implies p is equal to 1. So what is the backward interpolation formula? That is y of x is equal to yn plus p backward delta yn plus p into p plus 1 by 2 factorial backward delta square yn plus p plus 1 into p plus 2 by 3 factorial backward delta q yn. So this is the formula. Then you just put the values that equal to, means we will go for the last. This is yn, so this data we have to use. Yn, that is 64 plus p is 1, backward delta yn, that is 37 plus 1 into 2 by 2 backward delta square, that is 18 plus 1 into 2 into 3 by 6, then backward delta q 6. If you simplify, you will get 125. Okay, so that will be the y of 5 is 125. See the beauty of the problem. See, if you study the pattern, this is 1, this is 1q, this is 2, this is 2q, this is 3, this is 3q, this is 4, this is 4q. Similarly, when we come to the outside, when it is 5, it is 5q. That result we get from the pattern, and the same result we are getting by Newton's difference formula. Okay.